Page 323, 6.1. Anybody watching this video is going to find out that I asked Alex a lot of questions during class. She's all nervous. It's funny. All right. 6.1 is using properties of exponents. Okay. You should already know most of these properties. Okay, so this should be semi-review for us. Okay. So we're looking down at the bottom of page 323 in the green box. Okay, they call it the product property. Okay, we're going to go through all these real quick. Okay, if I have two things that are the same, but with exponents being multiplied together, what do I combine? What do you do if you're multiplying?
Like add them?
We add them, yes, exactly. So it's going to be a to the m plus n. Okay. An example would be like if I had x cubed times x to the fifth would be what? X to the eighth. It'd be x to the 3 plus 5, which is x to the 8th, right? Yeah. Okay, that would be a good example of that one. We already knew that, right? We knew to add exponents. Okay. The next one is the power of a power. Okay. Which is when you have, for example, a to the m to the n. So I'm taking an exponent and I'm raising it to another exponent. Okay, so a good example, or this would end up equaling, what do you do with those? You multiply them, exactly. So you have a to the mn. Okay, with x's, it might be x to the second to the fifth, which would equal what? X to the 10th. Okay. The next one, they have power of a product. Okay. Which is when I have two things being multiplied together and then raised to the same exponent. So I have AB all to the m power. Basically, you distribute this, exactly. This would be like a to the m times b to the m. Am I spreading those out far enough? Okay. You with us? Wasn't talking to you, but thank you. I'm glad you're with us as well. Okay. So if I have 3x squared, okay, that squared goes to what? Both of them, both the 3 and the x. So I get 9x squared, which would be written like that, correct? I don't know if he's too impressed yet, Mitch.
It's not.
Okay. Talk yourself up, talk yourself up. Okay, this one is the negative exponent. Okay, so if you have a to the negative first. Okay, this one might be a new one for you. Or they do negative m, because we don't want numbers yet. Thank you. Okay. One rule that we need to remember is that we do not want negative exponents. Okay, that's not okay. So we got to get rid of that. Okay, to get rid of that, we need to move it to the bottom and change the sign. So it's going to be 1 over a to the m. Okay, basically it's the inverse. Okay. Now, if you're having trouble remembering that, okay, just remember if you cross the line, you change the sign. Okay? Okay? So if right now it's on top, right? And this is over 1, correct? If you cross the line with this, that sign changes. Okay? Or if you want to think of it the other way, if you need to change the sign, you need to cross the line. Okay? So if I have, let's say I have x to the negative 6th, okay, we want to get rid of that negative exponent, so I need to do what? 1 over x to the 6th, exactly. Now also remember, if I happen to have a negative exponent on the bottom, if I move it to the top, the sign changes. Okay? So maybe you have, let's do another one real quick, 1 over 3, or x to the negative 5th. Okay, can't have negative exponents. So I'm going to flip that, and it's going to be x to the positive 5 over 1. Okay? Anytime you move it from the bottom to top or top to bottom, your sign on your exponent changes. Okay? With us, Carissa? Okay, the next one is called the zero exponent property. Think that's funny? That doesn't even surprise me. Okay, which basically just tells you a to the 0, as long as a does not equal 1, this works. I think that's right. Yeah, if a doesn't equal 1. Okay, this is going to equal 1 every single time. No matter what it is, or excuse me, a can't equal 0. A cannot equal 0. Okay, but anything else, anything to the 0 power is just 1. So what's 12 to the 0 power? 1. What's w to the 0 power? 1. Mitch. Anything to the 0 power is what, Mitch? So z to the 0 power is what, Mitch? Okay. What? What? Z to the 0? It is 1 because it's to the 0 power. Huh? No, doesn't matter. Because no matter what you plug in for z, it's going to be 1. So it's just 1. Alright. The next one, I have quotient power.
Why is it 1? Why isn't it 0?
Huh?
Like, why is it 1? Why isn't it 0? Because anything multiplied by 0 is always 0. It's not multiplying by 0.
It's not multiplying by 0. So basically you're taking some number, but you're not multiplying it at all.
Yeah.
So you only have one of them. Is the best explanation I can give you.
But if that one
Because if it was a 1, then it'd be whatever that number was. If it was squared, it'd be...
If it has a 0 exponent, why isn't it just like that?
What?
Like how it's like a 17 exponent 0.
Because
How come it's not just
to the first power would be itself. Because you're multiplying it one time. You're only multiplying one of them. I can't explain to you why it's not 0. I couldn't tell you that. But it wouldn't make any sense to be that number because 9 to the first power is 9. So it can't be that. But, so 9 to the 0 power is 1. I can't explain to you why it's not 0, though. I can't say that. Okay. Alright, quotient power. Okay? Or actually, it says quotient of powers. Quotient means what? What are we doing if we have a quotient? We're dividing. Okay, so you have a to the m divided by a to the n. Notice this only works if these are the same. Okay, if that was an a and that was a b, this doesn't work. Okay, but this is going to be equal to a to the m minus n. Okay, so when you're dividing, you do what? You subtract. Up above, when we multiplied, we added. Okay, so an example of this, now I'm going to do one that doesn't work. If I have 3 to the second over 4 to the first, can I do 3 to the 2 minus 1? No, because that's a 3 and that's a 4, right? Okay, but if this was a 3, now this would be equal to 3 to the 2 minus 1, right? Which is just 3 to the first, which is 3. Okay, so we're not going to do all of these with variables either. We're going to be using numbers. Thank you.
Could you still...
Everybody.
1 second, guys.
Could you still do a common denominator? Like, if the bottom one was... if the bottom one was still 4, couldn't you multiply it by...
But then it would change the top also. It would never be the same. That's a good thought, though. Okay, and the last one is the power of a quotient, which is another one that you guys probably already know, because we've talked about it. Make sure I write this properly. A over b to the m. What do you have to do with that exponent? It goes for both of them, exactly. So it's a to the m divided by b to the m. Just make sure that goes to both of them. Okay. Now, the problem, it's not a problem, but one thing we're going to have to be aware of here is that when we're doing these, it's not going to, they're not all going to be the same. Okay, so you're not going to be able to just know how to do one type of problem. You're going to have to be able to understand these properties. Okay, because it's kind of like geometry, where it's the same thing, but we have to do a bunch of different things to get to the answer. You guys get what I'm saying? Like, it's going to be the same process, but it's going to be different problems every time. Carissa, it's going to be okay, Carissa. Carissa, everything will be okay. I promise. Okay? Yes, it moves. You guys will get used to that. We're going to use this a lot throughout the year with basketball. Okay, so let's go ahead and let's do a few examples real quick. Okay, they're not going to take us long. I have, let's say I have 2 to the second to the third. Okay, what do I need to do with my exponents? Multiply them, because I have power of a power, right? Okay, so I actually have 2 to the 6th. Okay, they're going to want you to evaluate these things. So 2 to the first is 2, to the second is, to the third, to the fourth, to the fifth, to the sixth. Okay, so I have 64 there. No, not yet. That's 2. This is 2 squared to the third power. Okay? Now, can you do this on a calculator?
Yes.
Yeah, you can. But if I put a variable here, can you do it on a calculator? No, you have to know these properties. Okay? Now, one that is going to get a little bit confusing is something if you have this. Okay? They'll give you 3 to the negative third times 3. I'll make sure I do one kind of like what they have. Squared. Okay? And let's actually change this to negative 6. Okay? So here I have 3 to the negative 6 times 3 to the second. What's the first thing you notice here, Derek? Okay, and actually that doesn't necessarily matter. Doesn't really matter. You were right, though.
They're the same.
Okay, the first thing we should notice is that that's a 3 and that's a 3. Okay, that's a good thing because now I can combine them, right? If they weren't, I couldn't combine them until after I solved. Okay? So right now, they're being combined with what? And if you're multiplying two bases that are the same, what do you do with your exponents? You add them. So I actually have 3 to the what? Negative 4th. Good. Okay, I added my exponents. Negative 6 plus 2 is negative 4. Okay? Now, what's the issue with that? It's a negative exponent. So Logan, what do I do with that? Yeah, so where does this all need to go? We got to flip it. So it's going to be 1 over 3 to the 4th power. Okay, now we got to figure out what 3 to the 4th power is. 81? Okay, so I have 1 over 81. That's going to be a hard one to notice. But you have to look and see if your bases are the same. That's going to be very important to us if bases are the same to each other. Yeah?
Can you still do it if the bases are?
Yes. The only thing would have to be, you would have to solve this one first, and then this one, and then multiply them. You'll figure it out. That'll be Alright, now, the ones I'm more concerned about are the algebraic ones. Okay, so if I have a squared over b to the negative third all to the third power. Okay, now a lot of times it doesn't matter what order you do things in. Okay, you just have to get it all done. Okay, so Brody, what's one thing you see here that needs to be done? Okay, so you want to take care of that. So it needs to go where? To the top. Okay, so we're going to get rid of that negative. So now I have a squared b to the third, and then I have all of that cubed, right? Okay. Devin, what's the next thing you notice that needs to happen? Okay, because I have power of a power, right? And that 3 goes to both of them, correct? Okay, so Mitch, on the inside I get to the 6, a to the 6th, b to the 9th. Okay, can I combine those two things? Why not? The bases are different. Okay, so can I go any further with this? No. Okay, now, would I still have got the same answer if I distributed this first and got 6 on top, negative 9 on bottom? Because then I'd have brought it to the top and I'd have the same thing, right? Hey, just remember there's multiple orders that you can do things in. Just make sure you get everything done that needs to be done. Okay, I have two more examples for you, then I'll give you your assignment. Negative y squared to the 5th times y squared times y to the negative 12th. We got to figure out, what does this equal? Okay, so first thing Emily notices, we can't have negative exponent. Okay, so let's get rid of that. So I'm going to do negative y squared to the 5th times y squared over y to the positive 12th. Okay, distribute my exponent here. So I get what, Devin? Negative y to the 10th times y squared. Oh, excuse me. Over y to the 12th. So now I have multiplication, right? And if I'm multiplying, I do what with my variables? Or excuse me, I do what with my exponents? I add them. Okay, so I get negative y to the 12th over y to the 12th. What's that? Because why? Because these are the same, aren't they? So what happens to a y to the 12th and a y to the 12th? They cancel. And I'm left with what on top? Just a negative sign, right? Which is negative 1. Okay, now real quick, I'm guessing nobody's ever talked to you about it before. Why do these cancel, though? Because if you're dividing, what do you actually do with your exponents? You subtract. So you would have negative y to the 12th minus y to the 12th, right? Or excuse me, that's not right. You would have this minus that, right? You'd have 12 minus 12, which is 0. Okay, that's why they cancel. Okay, you've always been told that they cancel, but they cancel because of your quotient property. That was from the beginning. Okay, so it came from, I had negative y squared, and then I distributed my 5, so I got negative y to the 10th. Just remember that this is like a negative 1y. So that's separate. That negative is separate. Okay, so then you do this. 10 plus 2, since we're multiplying, gives you 12. So that's how I got my negative y to the 12th. Good there? Okay. Now, obviously, are they going to continue to get a little harder? Yeah, there's going to continue to be more steps. Okay, let's do one last one. A lot of this is just going to take practice. Okay, you're going to have to be able to practice this to get to the correct answers. So I have rs squared divided by r s to the negative first cubed. Okay, I do. I have to get rid of my negative exponent, except there's one reason why I can't do that yet. Because right now it's connected to the what? To the 3. Okay, so let's first, before we do that, distribute my 3. Okay, but you're right, we do have to get rid of that. So I have r s squared over what, Jedediah? Does that 3 go to the r too? So, yeah. So it's r cubed s to the negative third, right? Okay. Now I can get rid of that. So Neely, how do I get rid of that negative? If it's on the bottom, it needs to go where? On the top. So I have rs squared s to the third over r to the third. Okay. Lorelai, anything else you see that I can do? add my exponents because these are both s's, right? Okay. So what do I get here, Aspen? I get on top, I get r times s to the, good, s to the fifth over r cubed. Am I done yet? Okay, I can cancel r's. Now, this is where it gets a little bit interesting. How many r's are here? There's 1, and there's how many here? So how many can I cancel out? I can only get rid of 1. So on top, do I have any left? No, but I have an s to the fifth. And on the bottom, I have what? R squared. Good. Okay, because I only canceled 1 out. And there's my final answer because I'm down to just 2 letters. Okay. Not too bad, right? Just a lot of little steps that you got to be careful of. Don't miss any of those little things. Okay, they do talk a little bit about scientific notation. Okay, we'll maybe touch on more of that tomorrow. We get out of here at 11:20. Okay, so we got plenty of time. Let me see what I have on plan book for our lesson. It does.
You just walk around the room. We'll do the mannequin shot and do it.
All you have to do is just make it clean.
Before you start this, let me look at it real quick. Make sure that's what I want. Yep, that's good.
It's still circle. Don't
Pardon? 48.50, yeah.